Okay, so welcome to the flooding module of the online class. So today I'm going to try and create a couple of short videos that kind of cover the lecture topic, the PowerPoint. So I know it's sometimes a little challenging just to cruise through the slides, so I'm going to try and elaborate on some of the information that might help you understand some of the information a little better. So let's get started here. So what we're going to look at, of course, here is we're talking about surface water. So we're talking about streams, rivers, lakes, all that kind of stuff. And why do we care? Well, of course, we care because we use it to irrigate. We use a lot of surface water to drink, provides transportation, can give us some power. Um, what we see for surface water is that it's moving in response to gravity. So there's always some type of gradient, which we'll introduce that term in a little bit, but it's moving from high elevation to low elevation. And in some cases, that can be fairly steep. In other cases, it can be fairly gentle. It's a very effective way of removing and moving sediment, so pieces. It's a great transporter of erosional material, weathered material. I'm going to talk a lot about weathering in this class, but the material that gets broken down on the surface is mostly transported by water. And of course, when it rains, which is our big source of water, it hits the ground and moves into these areas, and these kind of zones that we want to talk about are called watersheds or drainage basins, if you like. And so what is that? Well, we can define it as an area that collects all the water and is funneled to some type of stream system. So in the diagram to the right, you can kind of see we're outlining this area as the watershed or the drainage basin. And we're defining that by every drop of rain that would fall on the surface here would be funneled into, in this example, the Fox River. Anything that fell outside that dashed line would then be funneled to another river system. And so we can estimate how much water can be pushed into the system because we know something about the area, the size of the watershed, and we also know something about the capabilities of the material the water's landing on, the soils and the rocks, to transmit that water into the stream systems. So typically what separates a watershed or a drainage basin one from the other is some type of high, like a divide. So in this view where you can kind of see a side view, you can see there's a ridge here that runs down the middle that separates two drainage basins, one to the right, one to the left. Rain would fall to the right, it's going to the right. Rain falls on the left, it's going to the left. And we use this kind of to define big drainage systems. So we can have huge systems that look like, let's say, the Mississippi River, or small systems that only focus on a small river system. And of course, something like the Continental Divide, which is the Rocky Mountains, is a huge drainage divide. Water that falls to the east of the Rocky Mountains is funneled, of course, to the east, and most of that water is going into the Mississippi. Stuff that falls to the west of the Rockies, right? That's kind of coming into our area, into Arizona and the Colorado River system. So there are a few different names we can use. Usually I'll probably refer to it as a drainage basin. And so here's some examples of some large drainage basins and the rivers that are associated with them. You can see the Mississippi is up there as one of the big river systems. And what you're seeing here for drainage area, right? That's just the size. How big is it? Some average length, width, or whatever the shape of it is. And of course, it's both given in thousands of square miles or thousands of square kilometers. What you'll also see is what's called a discharge, another term we'll introduce in a few minutes, a couple more slides from here. CFS means cubic feet per second, or if we do metric, it's cubic meters per second. So in the US, we certainly use the cubic feet per second. And so what that says, when you look at these big volumes, is figure a cubic foot. So something that's a foot wide, a foot tall, and a foot deep. So a square, a cube of a foot by foot by foot, maybe the size of a basketball, even though I know that's round. Um, Moving past you, if we were to look at the Amazon and you stood at the edge of the Amazon River and the water rushed past you, there would be 6,183,750 basketballs would go by in 1 second. So that's a lot of water. So certainly these are very large systems. And you can see at the diagram at the bottom, defining the drainage basins, there's some very large ones, which the Mississippi River Basin, all of that area in tan is collecting water from other rivers, the Ohio River, the Mississippi, but ultimately they end up in the Mississippi River down here, right, and they exit into the Gulf here. And so they can be very large. Here's the Colorado, right, the one we live in. So materials come in here, but there's also another divide that takes things through Texas and things like that. Arizona, yes, we're part of the big Colorado system, but we can divide that into smaller drainage basins based on some other rivers. And you may have heard of some of these. The Salt River has a drainage basin. Means all the water that falls in this yellow area will enter into the Salt River. If it falls to the north right here, it's going to end up in the Little Colorado, the Verde, and all those kind of things. So we're defining them by mostly topography, right? Where the water is going to flow and in what system. Okay, so some things about rivers we want to kind of look about and things we're going to talk about. The base level, what is that? So that's the ultimate ending point for our river. Now, sometimes rivers will flow into another body of water like a lake, and that would be the base level. Whatever elevation that lake is at would be the base level for that river. So it can't go below that. So there's some elevation above the base level. So let's say we're flowing into a lake. You're up in the mountains, the water's moving down, right, from a high to a low, and ultimately ending up in the lake. Mostly base level is sea level, because most streams are driving toward the oceans, toward the sea level, and that's kind of the ultimate base level. Now there are some stages how rivers grow and develop over time, and I want you to be able to kind of distinguish between young and old river systems. And we can do that if we look at some features that hopefully we can be able to identify, and then we can talk about how you can visually look at something and say, oh, this is the old part of the river, and this is the young part of the river. All right, so I'm going to pause here just so you don't fall asleep, take a little break, and then we'll start up another video and continue from here.